Okay, I'm connected. Can you start it up? Yeah, no charge on the 12-volt battery. Hello again from the workshop, where today we've got hopefully another interesting case. OGS Mechanics Hybrid and EV. This BMW comes from Germany on recovery because has developed a problem. Battery light coming on, 12-volt system not getting charged, and I think we're gonna have something different than we ever did this time. Let's get into the workshop and see exactly what it's all about. Didi, let's put it inside. Hello from OGS Mechanics. I'm George, and here we fix cars, all type of cars, electric, hybrid, combustion engine cars. Have a look around and follow me for interesting repairs translated in videos. Can you pull up the bonnet? Okay, and turn the ignition off. Battery light coming on while driving. Everyone, well, on classic cars, you'll think about an alternator failure. But you know what's one of the great misconceptions that I see very often? If the battery light comes on while the vehicle is driving, the fault is the battery, the 12-volt battery. It's never the case, because the battery is just an element to store charge. And if that light comes on while the vehicle is driving, is because there's no charge going to the battery, not because of the battery itself. So in this case, this is being a hybrid, there's no alternator on this. The part that is charging the battery is the one over here. Is a comprehensive part, which is an inverter and a DC converter. So that's the part that is supposed to charge the battery if everything goes fine. Now let's run into a diagnostic to see what is all about. Didi, I think we need to have some charge because the battery is low, and we want to scan the car to see exactly why this car was stuck in Germany. Yeah, funny enough, this customer has found it through our YouTube video. So if you like our videos, don't forget to subscribe, click the notification buttons, because often we have hopefully interesting videos from the workshop with how we repair cars in general, electric and hybrid with specializing, but we also do the other type of cars. So let's see exactly what's happening with this BMW. Where do we start, Didi? With a scan. That's the first thing that we're gonna do. We want to see exactly what error codes we're going to find on the vehicle. And for the 12-volt system, we mainly are going to focus on the high voltage system for that. So we're going to scan just the 4 control units, which are the battery management control unit, the electric motor inverter, the charger, and the air conditioning. So in the charger module and air conditioning, there's nothing. We have a lot of error codes in the battery management, and one of them relates with the under voltage at one cell and also over voltage at one cell. It's interesting, under voltage and over voltage at one cell. It'll be a bit hard to understand that the cell voltage might go low and high. It can go low if the cell is bad, but it shouldn't go higher. So I'm not suspecting a cell, maybe the sensor being defective. Let's see what other error codes. In the inverter control unit, we have a lot of error codes, but they'll be linked with the one on the battery management control. Now, one next thing that we're going to do before we start stripping is to read data out of the car. In the battery monitoring control system, the error codes are permanent, and now we want to see what exactly we're reading out of the battery. Cell status, correct. So what is very important to see between the cells?
The difference
the balance here. So we have to see whether any of them are out of balance. Ooh, we do have 132. And if we look at it, it's exactly the module 2 because that's exactly where the faults, the error codes are. Now, one important thing is, have a look. So this 3.8, where the other one are around 3.6. So we have cell number 27 having a reading of 3.8, where all the others are 3.6. Well, this is a bit strange to have a cell reading higher than all the others when they are connected in series. Is a bit difficult unless the cell is very bad and gets degraded. If the cell is bad, under driving condition, you're going to see a lot of fluctuation, either going very down on, or under load, or obviously when it's getting charged going very high. What should we do from here, Didi? What is your next plan of action? To get to the battery, because what we have to do, we have to prove who's right, who's wrong. So is the battery sensor reading correctly the voltage? Or is the cell? So if, for instance, we're going to have good reading, the same reading when we're going to read with the multimeter for the cell number.
We should get the same.
Which cell?
Number 27.
So the 27. Pack?
Pack 2.
Okay. How many modules in this battery?
6.
6 modules. So 6 module pack 2, cell 27. We have to see exactly with the multimeter on. Do we have exactly 3.8? 824, be more precisely, where all the others are running on 3.6. And this is yeah, cell 27. Temperatures, they all run fine. This is the one. See, where you look all over 3.6, because normally when we're looking at this figure, we want to be 2 digits and as close to 0 as possible. 20, 30 millivolts, 40, a bit stretched, but we have 132, so not good at all. Okay, in this case, what are the preliminary steps before we take the battery off?
We need to take the negative out, the service connector to be removed, and then the plugs for the high voltage to be removed.
Well, if you disconnect the battery, that's going to be enough, because the BMWs, they don't have a service connector. Yeah. Next thing on the BMWs, how is the battery cooled?
With the AC.
Perfect. So we need to drain the AC gas, recover before we'll put the car up on the ramp. What we have to remove to get to the battery?
The negative.
No, up on the ramp.
Before we.
When it's up on the ramp, what components we have to remove? You'll show me when you get there. Didi's learning, still learning. Okay, let's take the gas out. Obviously disconnect the battery and then prepare the car to lift it up on the ramp. dismantle this BMW. Why did you do that, man?
To get to the battery.
Yeah, to get to the battery, and now we need to get into the battery. So everything is done, even the cover is undone. So ready to get inside. Okay, I thought there's a strange smell. So our problem is with pack number 2. Which is number 2, did you?
It's in the front.
This one. Okay, so what we have to do, we have to take this pack out. We should be able to do that straight away, no? And measure which was the cell that?
27.
27.
It was showing 3.8 volts.
3.9, and all the rest they show is 3.6. 3.6, yeah. Okay, let's see what we have to do. So we need the Torx. If you can have me a magnet, please. Those are long anyway. I think we should have enough clearance, shall we? If you can hold it like that. So this is one of the module of a G series battery. So inside there are 16 cells which together they form a module. This is the control unit that grabs all the data from the modules, voltage, individual voltage and temperature, and then send it out to the battery control unit. Now what we want to do now, we want to take the cover off and get to each cell individual and check exactly. We want to find the cell number 27 to see if indeed it's reading higher than the other, or is actually this little control unit or the sensor that comes from it that reads incorrectly. So let's see which one it is. I think we need a flat screwdriver, Didi. So which one is 27? Where'd you start counting from?
From the positive.
From left to right. Which left? Which is left? I don't know which one. I just, so we have to calculate 27. So 27, we got 16, number 1. This is number 2. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 27. So it's either gonna be this or 7, yeah? Or this, am I right? Go on. 3.693. Go on. The other one. Yeah. Oh, 3.8. Okay. Some math is a bit different. So we did indeed have a cell that is reading 3.8. This is very, very strange. Very strange to have in the serial connection to have a cell that is charged more. That'll be something, never came across to it, but it looks like the situation. Problem with those modules is that they are welded to have them dismantled, because in here it looks like there's only one. There is some procedure available. We don't have it yet. Hopefully we'll have it at some point. But having this difference, I mean, we could potentially discharge that cell and have the battery balanced. But the concern is, why did happen? Is it gonna go again? Because obviously an imbalance like that will trigger an error code and the car no longer runs. So I think we are left in a situation where at this stage we're gonna replace the whole module, because it looks like there's a problem with the cell 27. So can you do again? Put a mark on the one. So 3.8. Yeah. Let's just have a mark here. Okay. We need to source a module and then we can carry on with the repair on the car. So in the background, we've been a bit busy ordering parts. So we have new battery control units and we have a new module, which hopefully now should be balanced. It was discharged and it's very important that to be level with the other ones. Let's do some measurements, Lal, and I think I'll rather also do the cell measurements. Yeah, each cell. So if we take the cover off, I'll prepare the multimeter. So we are obviously interested to see that we have no difference between the cell as we had in the one that we're already replacing. Obviously, state of health and capacity should only be determined once we have the car under load. But we have a good feedback about this pack, so it should be in good condition. So let's get and measure them. Do you remember what we had on those initial one?
59.71, 17 like that.
17, but what was the pack voltage? So let's see what we have. Our pack voltage, first of all. No, the pack, the total. Total 59.6. And the other one?
59.17.
17. It's about 40 millivolts, just about over the pack, which is yeah, which is good. Let's see the difference between the cells. 3.72. 7.1, perfect. 7.2, yeah. 7.2, yeah. 7.2, yeah. Good. Good. Perfect. Yep. Yeah. 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 One more or two more? Yeah. Perfect. Yeah. Okay, so far so good. The measurements are looking good. Obviously the real test is only when the car is going to be driving. So, but so far we have, as it looks, a good module that we are getting ready to install on the car. The module that we're gonna replace also comes with the slave BMS, as it's called. This is a battery monitoring unit that gets the data from the battery, the cell voltages, individual cell voltages. Can you take the cover off once again? As I want to show you something quite interesting. So what is inside the cell, because it's not just the module separate, it has some sensors, very important for the operation of the battery. And this is applicable pretty much to all batteries. So let's see. So each, if we look, each cell, it has a voltage sensor, and we have temperature sensor 3 within the battery pack. So those on with reds are temperature sensors, and the other one are voltage sensor. Okay, let's put it back. We'll obviously, like I said, because trying to understand why the voltage has increased in one of the cells is a very interesting thing, because it could be, when it goes down, it's pretty much going to be a cell issue. Now, if it goes up, one of the cell is higher than, which end does it come? If one of the cell is higher than the other, it could be that actually this module is not controlling correctly, or it could be still that there's an issue with the cell. Nevertheless, we're replacing the whole lot. So we are ready to go. Okie dokie. Let's take the cover off and let's get prepared to install the replacement. Inside it's high voltage. Yeah, whenever you're ready. Da-dum, da-dum. Okay, I'll take this. Can you keep it there, Daddy? Thank you very much. So this is, I remember now, this is the one that we're struggling to slide it in. So this is the location, and obviously this is the module. Should we replace it now? Yeah, let's replace it now. Will it be? No, we have to connect it. I was just wondering, it would be easier if we can slide the battery without it in. Huh?
Put the battery, we can because we get little more space here.
Yeah, but we have the bolt down here.
Yeah, that we can put.
Oh, we can slide it in.
Yeah.
Okay, let's take it off completely then. Screwdriver. Yeah. We're gonna take this control unit out because we're gonna make a bit more room to slide in the pack. And here, this is one important aspect here. This bed where the battery sits on is actually the cooling of the battery. And you know one strange thing? I mean, strange, interesting thing. So this is so critical for the operation of the high voltage battery because it keeps the battery cooled down. And soon we're going to have a very interesting case with a vehicle that it has low mileage and the battery has failed, state of charge very, very low. And the reason, after I've done some digging and talking with the customer, it was the car was running without air conditioning, and without you really realizing, this is degrading the battery very, very easily. And the strange thing, no warning lights. Are we ready?
Yeah.
So AC has to work all the time on the hybrid vehicle, even electric, because it cools down various components from the high voltage system. So we'll talk more when we're gonna come to that. Okay. Are we ready? We're gonna slide it in. Not sure how we kept this. This is a bit of a Really? It wasn't too bad. I think it took us a lot. It was harder to take it out then. So what are we going to do also, after we're going to secure the battery, first of all, we are going to connect to the battery control unit, the replacement one, and we want to read stats about the battery before we're going to go and put it on a car. So we want to make sure that we are still within tolerance for the balance. Yeah. Okay, do you have so if I'll do that, you can replace the SME? Yeah. We need to get this for Didi to fit it on the car. Didi,
Yes, sir.
while we're installing this battery, what should be the cell voltage on a lithium-ion battery?
Cell voltage of lithium ion. Yeah,
Of a cell.
3.6.
3.7,
6.5 to 6.7.
yeah. And minimum?
Minimum should be 2.8, 2.7.
2.4. So why is important? If one of the cells drops below 2.4, which is, it takes quite a lot considering it's 3.7, the nominal voltage value, the battery is no longer safe to be charged. A very important aspect. Anyway, did we ever had one dropping so low? I don't remember.
Still we didn't get below 2.4.
We didn't get. So it has quite a big tolerance if you think about it. And maximum is? 4.2. So from 2.4 to 4.2, nearly 2 volts, so 1.8. So quite a big tolerance, the lithium-ion batteries. Nickel metal hydrides, they have a lower tolerance and low voltage per cell, but have we seen one of them? No, all told us, but we haven't done, yeah. I think I've done a while ago, but we haven't done for a while. So, can we get ready to connect your diagnostic tool? Yeah. So we've set up the connection of our diagnostic tool, and we actually have very good stats. So this is what we're interested to have a low value, and our module has got 3 millivolts difference. So all quite well balanced, cell status, all looking good. So we do see a slightly higher charge on the pack that we've installed, but well within what we want to achieve. So we're quite happy with this. Saying that, we are kind of ready to put the cover on, so we can, just disconnect. Fine. It's very hard with those gloves to do anything. Eh? Lal, I'm ready with the cover. Anything else we have to? Yeah. Anyway, we haven't taken the other one. The seal, it's in place all across. Yeah. That's good all over here. Okay, okay. So the high voltage is now left inside. We can take the gloves off and start sealing the cover, putting all the bolts, and the battery is ready to go back on the car, and hopefully we're gonna get BMW running. Is that so, Didi?
Yes.
So Didi is going to install the battery back on the car. Didi is level 2 and 3, and he's gonna become level 4 soon. Yeah? Good. Good job. Didi had a good idea. We're not gonna say what was. We're gonna tell Didi we applied his idea. No, we're not gonna tell him. Didi, we applied your idea, man. We're not gonna say what it was. We need more. He has more. So let me tell you what was the idea, honestly. We didn't want to say, show this, put them all here. So we had to lubricate the bolts, and what was, because there are so many bolts to be lubricated, and we decided to do this. And they're all lubricated now. And look, they look very good. And we're gonna make sure the thread is properly protected, because the body of the battery is aluminum, and it's very easy. They can cross-thread it if they dry. Anyway, we said it now. Well, so we are ready with it to give it to the capable hands of Didi. Let's take it to the garage. Very sunny today in London. Didi, we've got delivery. Yes, please. So how are we gonna pull it in or push it in?
Yeah, you just go to the back side.
Okay. So reversing. We can turn around. Then we have to turn around the battery on the, yeah? Okay, yeah? Okay. Oh, okay, like that, yeah? Turn the battery. This way, yeah? Is he aligned? Yeah, okay. So let's go up. Tell me as we go closer. Looks to me a bit more to the right. How does it look? Yeah? I think we can slide the battery because it's not that heavy on the trolley, no?
Yeah.
Can you try?
My turn off.
Going?
Yeah.
Correct. Just seconds, let me check. Yeah? Going? Yeah? Are we there? Are you okay? Did you there?
Yes.
Lal, are you okay there? Yeah?
Yeah.
Perfect. A lot easier the hybrid battery because they are so smaller. We had complete electric vehicle, and that's very hard to set it up in position correctly. With this one, it's playing with it. Perfect. I've got clear instruction. We can drop, yeah?
Yes.
Perfect. Perfecto. So the battery is in position pretty much. From here, we don't no longer need a table. We can adjust it, just ever so slightly because there's a bit of movement in it. And then we'll start to connect everything back up. Regas the AC, coolant, and so on. No? 2 seconds, we need to slide it in here. Did he? It's just about, I don't think we'll be able. Okay. So we are getting very close. After this reinforcement bar that we have to install, we just need to regas. So everything is in place. We've done the programming.
Yes.
And programming being done, we know the battery is good. Obviously, we have a bit of charge on it, but we'll do a short draw test and then we'll put it on charge to assess the battery fully. Obviously, the range, the balance. Yeah. Okay. The actuator on the exhaust. You have another one here, Didi? We already have everything connected, also the 12-volt batteries. We are ready to drop the car finally down, while Didi is still checking the coolant levels. I think we're ready to have the ignition on. There's one more thing that we have to do, which is regas the AC, but we're gonna do it in a different bay. So we should hopefully have the car running without any warning messages. Bonnet open, this is okay. Let's see. 2 miles, yeah, the battery is low, but still, because the bonnet is open, the engine kicks in automatically, but we have no error codes. And one thing that you notice straight away if the 12-volt system is getting charged on those BMWs is that the idle speed is increased. You can hear it straight away that it's slightly increased. It's not the case. Everything looks good. After we're gonna do the level checks, we're gonna take the car out to AC regas. Then we're gonna do a short road test. Then we'll put it on charge. We wanna see a range test and cell balance in a drive test. But so far, all looks good. We've got also the level checks, and one important thing, those BMWs, they have two cooling tanks, and because one is for the engine and the other one is for the hybrid system. Very important, both of them, they have to be at the right level, and they use this a special coolant because of the high voltage system components, as the coolant is running through those components. So we are ready here. Didi, how are you getting on?
Just 2 more bits and it's going.
Yeah, perfect. Just finalizing the boot covers. We are ready, and we should also have ready on the dash electric mode enabled. And once Didi is ready, are you ready, Didi? We are ready to take it for the AC regas with a fully working EV system. And while we're gonna have it regassed, we're also gonna plug in the charger to have some charging for the battery, so we can then test a bit the battery stats. That's it. should go blue if everything goes fine, which it is. And this is pretty fast, 7.5 kilowatts. So we should have in the, I don't know, 20 minutes, half an hour, we should have a bit of charge in the battery, good enough for some initial testing. Didi, are you connecting to do the AC?
Yes.
Perfect. Didi is going to take care of the AC, and then once this is done, we're going to head out in a road test. AC regas has been done, and we decided to leave the car on charge because with those chargers that we just installed, it was much quicker to have the battery charged over 2 hours, and we have the battery fully charged, and we are ready to go in a drive test to assess the battery balance, range, and test overall the functionality on the electric system and the vehicle in general. So we have battery close to 100%, all good to go out. After I'm gonna put this safe. We are getting ready, so interesting, we have a range of 35 miles, which is quite good. We're gonna reset the trip. Hold on. Yeah, so the blue one is gonna show our electric drive, so this is what we interested in. And here we have stats about the battery, state of health very good, 98, battery quite balanced, 23 millivolts, exactly what we'd like to see. Just curious, see, we still, if you look a bit careful, you see the hour pack still slightly higher, and it is one of the cell in our pack, but it's only 20 millivolts, so it's fine. It's exactly what it should be. So we are ready to proceed. Let's go and see how many miles this battery is gonna give of pure electric drive. For this test, as always, we'll emulate some ideal conditions, and this is because we do all the tests on the same condition. And by ideal condition, what I mean, no fan, obviously no air conditioning or heating at all, lights not used, it's daylight, and we're gonna put it on cruise control. We're gonna go on the motorway on cruise control, set as this speed 65 to 70 miles per hour. So because we like to have an understanding about the range under those conditions, and that's how we test every car. So to have a bit of understanding from one to the other, and we know this G20 BMW usually it does on pure electric drive between 25 to 35, depends on the battery, but a good battery it should be over 25. Let's pull on the side. The balance is very good, so we managed to balance the new module very close to the others, which is a very, very important aspect. Also, while charging and charging the module, the battery monitoring system tends to fine tune the balancing of the battery, and we can see that by the figures that we see here. So all stats are looking good, pretty much as to what we expect. So far we've done about 11 miles, still shows a range left of 18 miles. Battery starts looking good, so overall seems all okay and in good condition. The battery and then the electric system operates correctly. Let's see how much we're going to get with the full battery. So we still have about I don't know, 55% left. So we should be in range between 25 to 30, exactly what we kind of expect. Our road test it's going a bit different because at the moment we are standstill. M1 outbound from London. It's a car park today. Anyway, we've been driven about 15 miles. Still shows about 9 miles, so it is good. We still have about 40%, and the battery is well balanced, 13 millivolts. So I'm happy with the stats that we see. What we're gonna do, we're gonna check the AC, make sure it also works. It blows nice and cold. He does pretty much straight away. Ooh, it's cold. It's good. We've tested it anyway when we regassed, because when you fill in, it tests the pressure in the circuit, so we knew that's working. So all looks good. Temperature within the battery, also an important aspect, 30 degrees. So what we expect the battery temperature is to be anywhere between 20 and 40. This is where the battery should operate under these temperatures for optimal operation and reliability, so to last long. So all good, happy with the repair. We'll head over to the workshop. It seems like the traffic starts moving slowly, but the battery range it's what we expect to see. So back to the shop, final checks, levels, and this car is ready to go to its owner, operating now. If you remember, this car came from Germany on a flatbed. It broke down. Now, quite an interesting thing if we think about it, because I've seen it in a few cases where the electric hybrid cars, like those BMWs, have been broken down due to an issue in the high voltage. And the question was, can you prevent that from happening? And maybe I haven't got yet clear information from all the customers. I didn't manage to speak in particular with this one, but the question is, do you notice range issues? Because what happens, first of all, when the battery is gonna be out of balance, first things first that we're gonna notice is gonna be range. It's gonna affect the range, so it's gonna have a lower range. So that straight away is a signal, and then if you react, then you can avoid being broken down, because what happens, the battery system runs and monitors constantly the battery, and then it starts seeing difference between cells. Obviously it's going to reduce the range, but then getting this continuously, eventually is going to flag up a fault, which is going to put the car in a lean mode. Obviously no more 12-volt charge, so this is a broken down reason. So if you pay attention, you can avoid those situations. So I think it's a good take from this situation, and from the similar that I've seen being broken down. There are signs, you have to pay attention to them. Yeah, we had also the AC on. We've been a bit stuck in traffic. Anyway, we managed to do 25 miles. So the figure below is the electric drive. Is very good. The car drove fine. The battery looks good. So we are okay to hand over the car to the customer. So all looks good. So the last more is just the final check on the level, but as in regards to driving, all good, tip top. Final checks been done on the BMW, and we kind of ready to hand it over. But before, let's do a recap on what was the job with this BMW that came to us if you remember, from Germany. So the car was broken down on Germany with the battery light being on, 12-volt system not getting charged. Came to us, run some checks. We concluded the problem is within the high voltage battery. We had to strip to investigate, as one of the cells within a pack, this is a battery pack, one of the cells, more precisely this one, was reading a higher, much higher than the other cells voltage. Therefore, the system went in sort of limp mode, so no longer operate, obviously, to prevent any major issue. And then, therefore, obviously, the vehicle was not drivable with a 12-volt system not getting charged. Now, all being fixed, what was the cost? As you've seen already, the fix. So, let's see. Now, we started with initial check where we try to understand where do we have to go. And for that, we charge 120 plus VAT. Now, we concluded we had to get into the high voltage battery and do some checks, because what we could read from the tool, it seems that in the high voltage battery the problem is, and obviously we have to strip to check, do measurement to confirm that. And we did confirm one module was faulty. We replaced it together with the control unit for it, and also with the control unit for the battery itself, because the error code that has trigger currently could not be cleared. We're working on a solution for that, but that's another discussion. So we had to replace the pack number 2, and we've done so with a second-hand part, trying to keep the cost down, and the pack was 250 plus VAT. The battery monitoring control unit, a new part, and this is 314 plus VAT. The total cost for us to have the battery stripped, obviously confirming the problem is within the pack, and to replace the pack, balance the battery, because this is also an important aspect, putting everything back together, programming the control unit, road testing the car, obviously A to Z. So the total cost for this work, it was 1,500 plus VAT. So this takes us to a total of 2,184 plus VAT. And the range that we got out of the battery on electric drive, it was 25 miles. However, if you remember, we've been stuck a little bit in traffic. We also used a bit AC. So I'm pretty sure we could have gone more than that, but that's fine. It is in line with our expectation. So it is a battery in good condition, and we are okay to hand over the car to our customer. So this was the repair on the G21 that was stuck in Germany, was fixed in the UK in our workshop in London in OGS Hybrid and EV, OGS Mechanics. So if you like this video, don't forget to click the subscribe button and also the notification button, so you are notified whenever a new video comes from the workshop, because in here we're going to have constant video with real repairs, where you're going to get a lot of technical information and also the cost, so for you to understand better the vehicles, and especially electric and hybrid vehicles. Subscribe, notification, and I'll see you next time.